Well, howdy there, Internet students. This is Mr. Hermanson again. This time we're going to be talking about trigonometry in area. How can you use trigonometry to help you find the area of regular polygons and triangles? So check this problem out and see if you can figure out a way to find its area. Remember that to find the area of a triangle, you need to know the base and the height. Go ahead and pause here and try and figure it out, and then you can check back for my solution. So here's the deal. This is an isosceles triangle. And if we draw in the altitude of that triangle, that should split it in perfect halves. That's an angle bisector. 90-degree angle. And if the vertex angle is 20, then that means this angle right here is 10 degrees. And we need to know this length here to find the area. And we do know that this piece right here would be 5 because it says that it's at 10 inches across the whole bottom there. So then I can just use some trigonometry. I got both legs, so I'm going to use a tangent here. And x would go on the bottom. 5 over x, opposite over adjacent, is equal to the tangent of 10 degrees. So I would do, to find x, I would do 5 divided by the tangent of 10 degrees. And that equals, my calculator is saying that's about 28.35. So let's say 28.4. Now in my calculator, since I need to use that for the area and I want to be as accurate as possible, I'm going to store that into x. Then I'm going to use the area formula for a triangle. It's 1/2 the base, which is 10, times the height, which is x, and that x is stored in my calculator, so I'm just going to type that x in directly so I can get it as accurate as possible. And if you were able to do all that correctly, and let's say now I'm okay with rounding it to the nearest whole inch, I would get 140 square inches is the size of the banner. All right, so that's kind of what we're going to be doing today here. So we want to find the area. And this regular octagon, I'm going to draw in the apothem because we need to know that. Now, if I were to draw in, like, say, one triangle, the vertex angle of that triangle would be 360 divided by 8, which is 45. So now I'm going to draw in this little triangle here. I'm just going to make a bigger view of that little triangle. So down here is half of the base, which is 3.75. And this is my apothem right here. And I know that this angle right here is going to be 22.5 degrees, half of this 45, which is the vertex angle. Now I have enough information, I can do a little trigonometry. Again, I have, with respect to that angle, I have the opposite and the adjacent. So we're going to say that the tangent of 22.5 is equal to 3.75 over x. And so to find x, I would do 3.75 divided by the tangent of 22.5. And so you know what I'm talking about. X is that right there. I'm going to do that on my calculator and store it in x. It's about approximately 9.05, but remember I stored that in x so I can keep it as accurate as possible. So I'm going to do, for my area, 1/2 times the apothem, which is what I stored in x, times the perimeter, which is 7.5 times 8, which is 60. And when I calculate that, and in the end, I'm going to just round it maybe to the nearest tenth, since it looks like we're using tenths here. And I get rounded to the nearest tenth, 271.6 square centimeters. All right, so I'm going to let you try that with this one, and I'll write down my work. And if you pause now and give it a shot, you can check back and see if your work is correct. Rounded to the nearest square inch, I got 200, or I got 27.5, so 28. All right, let's try another one here. On problem 2, we're given a radius of this hexagon, and we want to find the area. So let's draw on that little triangle. And in this case, we don't really need to use trig here, but since that's what we're practicing, we're going to do. And the reason we don't is because it's 30, 60, 90. But let's get the apothem we need. So this is a 60-degree angle and a 90-degree angle in that triangle. I'll just blow that up a little bigger here. So to find A, let's call it X now. That's our apothem. This angle is 30 there. And we know that this length is 6. So we have the hypotenuse and we have the side adjacent. So we're going to use the cosine here. So the cosine of 30 degrees is equal to x over 6. So x is equal to 6 times the cosine of 30 degrees. I'm going to go ahead and use my calculator, figure out what that is, and then store it in x. Now I'm going to do for the area 1/2 the apothem, which is x, times the perimeter, which is, we need to find one more side for that, don't we? But I'm just gonna, since this is a 30, 60, 90, I know that this would be 3 here, that those are all equilateral triangles in that hexagon. So this is 3, so the perimeter would be 6 times 6, which is 36. Multiplying them out and rounding to the nearest square foot, and I get about 94 square feet. All right, I think you should try one like that. Go ahead and find the area of this decagon. Remember, to find the angles, you need to do 360 divided by the number of sides, which is 10. Okay, so here's my work, and what I did is I used the letter A on my calculator. It's right above the math there. You have to press the alpha button first. And so on my calculator, it looked like this: 0.1/2 times A times 20x. And the reason I did 20x is because remember, this part x is just half of one side. Since there's 10 sides, I need 20 of those x's to make up the perimeter. So this here is the perimeter. And when I did that, so this is as accurate as I can get it. And I want to do it, round it to the nearest square inch. If you did that correctly, you got 265 square inches. All right. Go ahead and read this essential understanding part. We're going to use this formula. It works pretty slick, but this is for areas of triangle when you don't know when they're not right triangles. So it's using trigonometry to help do that. So here's the formula we're going to use. The area of the triangle is 1/2 BC times the sine of A. So basically you need to know 2 sides and one of the angles to use this formula. So The area of this triangle here is 1/2 B times C, so the two sides you know, times the sine of the angle, and that angle has to be included between those two. So this would be A right here in this triangle. So we're going to do 1/2 times 8 times 12 times the sine of 36 degrees. And we're just going to put that in our calculator. It would seem appropriate to round this to the nearest whole number, so we're going to say that this area is about 28. The reason I said it's appropriate is because these are all whole numbers. So we couldn't get any more accurate than the nearest whole number. So it's about 28 square centimeters. All right, why don't you try one of those, see if you got this idea using this formula. So here's what your work should look like, and rounding to the nearest square inch, you should have got 45 square inches. All right, looks like you're ready for practice. We'll talk to you soon.